Hello guys and welcome. I hope that you're well. My name is I play 4K, AK I play 8K, AK I play 16K or UHD King. During this video I'm going to show you War Thunder running in 8K resolution, natively rendered with the help of single Titan RTX video card, Nvidia's Turing GPU architecture, and two Xeon's E5-2699 V3 processors running on a single motherboard in dual socket motherboard with 178 gigabytes of system RAM, and each Titan RTX has 24 gigabyte of VRAM, which is the video RAM, but I'm only running single Titan RTX to avoid any hot pockets between the video cards. Okay, the stats at the right top corner self-explanatory, but this video will be all about benchmarking. So we're going to benchmark this computer for those folks who is looking to build low budget system, doesn't have a lot of money, looking into the workhorse like a workstation for 3D rendering, that doing it fast and nice, and as a graphic designer, as well, like uh, video encoder. So let's say if you're a YouTuber or whatever, 8K resolution video encoding through FFmpeg++ application, video encoder application that I'm developing will utilize all the 72 logical cores out of those two Xeon E5-2699 V3 CPUs. But today is not about that. Today is about can it game and War Thunder in 8K resolution. So I'm going to show you all kind of different presets. Pretty much I'm going to show you maximum visuals, which is I set at the maximum visuals. Then I'm going to show you possibility high, medium, and minimum. And right now it's set at custom, as you can see. So this is the maximum visuals in 8K resolution, pretty much without the anti-aliasing, and like that. So this is how we're going to start it. I'm going to play the replay, which is one of my replay, as again this is not about the gameplay, and it's going to demonstrate pretty much starting with the low GPU computing but still very high GPU usage, and then going to the extreme. And this replay I'm going to use in all uh, test in War Thunder in 8K resolution. I'm going to share this replay with you guys in a link down below, so you can download it as well and test it with your systems. Yeah, so this system as workstation, those CPUs from 2015, each of them was $5,000 in 2016, but I purchased for $125 each, $250 total, and the motherboard was $110. I'm going to put all the links for you in the video description from Amazon, from a good sellers, exactly where I purchased the motherboard and etc. And it's running on the Corsair H150i Pro. Um, one of them from my gaming rig that I didn't use for 8 months, which is the Core i9-9900K, overclock at 5.3 gigahertz, which is amazing gaming rig, by the way. But I didn't use it, so keep that in mind. And pretty much you can do anything on this workstation. I'm so in love with this workstation. $400 without the video cards, and of course I installed the two Titan RTXs when I'm doing the extreme gaming scenarios, but usually it's running single Titan RTX, and I'm doing the 3D rendering in 3ds Max, Cinema 4D, or Blender 3D. A lot of tutorials are coming over the UHD King, as well as I'm doing some Bitcoin mining as well on this system. It's beautiful. I can mine the Bitcoin through the video card Titan RTX, and I can do the 3D rendering while utilizing the 72 logical cores of my CPUs. Out of the two CPUs, 36 logical cores per each. So it comes with 18 physical cores, and hyper-threading technology enables another 18 logical cores, so 36 logical cores. And you need to have this system only when 72 logical cores are utilized, at least at 90%. This is the only the scenarios where you're going to take a benefit out of. Just keep that in mind. And if you're building a gaming rack straight for games, there is a different scenarios and different systems that can be used for the similar money, and it will outperform out this system. But as again, this is a workstation designed to work for the heavy loads when every single core is utilized at least at 90%, such as FFmpeg++ application that I'm developing as again while I'm doing the 8K resolution video encoding, and I'm using a lot FFmpeg++ application, guys, and hopefully you're gonna love on it as well. Very soon I'm gonna share it with you as a freeware because it's going to be based on the FFmpeg library, but my application will be for a regular user and it's going to be amazing. Also, it's going to have a CPU benchmark that you don't want to miss. It's going to be like 3D Mark. So as you can see, I'm very skillful and pretty much experience when it comes to software development, game development, graphics design, 3D artist, 3D animation. So that's why you want to watch my videos. So guys, as you can see, I didn't move the camera. It is what it is. 8K resolution native right now, 100% scale at custom preset, which is the pretty much maximum visuals. This is pretty much how I would run it, and FPS is like about 40 FPS. Keep in mind that today I'm recording this video with Nvidia Shadow Play. It's a beautiful software that has the capability to capture your screen in games, in the desktop, when you're doing some application work, and it's utilizing some resources. So without the recording, it's going to be 3 FPS higher. Keep that in mind. But still pretty amazing result for a single Nvidia Turing GPU architecture video card, which is the flagship, but pretty much similar performance will be on the RTX 2080 Ti video card, which is the gaming video card, and Titan RTX kinda like a for the desktop users. Keep that in mind. Alright, I'm not gonna move the camera because just in case. During this footage, as again this footage is a computer science, so I'm not gonna make movements, so we can utilize this footage when we're going to compare the future PC, the future video cards, the future GPUs, the future CPUs. I cannot wait to compare with the mobile devices by Apple, the results. It's beautiful, guys. As you can see at the right top corner, the data updated every second, self-explanatory. As again, when there is nothing going on or just light things going on the scene, the FPS is about 45 FPS average, but wait up and it's going to be boost up in the heavy scene, and this is going to be very extreme end of the benchmark. So this video is going to be about 1 hour, but I'm going to test all the resolutions just in case. And I'm recording this video through the Nvidia Shadow Play in 8K resolution native as well, because the Nvidia driver, the latest Nvidia driver in December 2021 is modified, and I have the capability to run DSR, which is to render my screen natively, to force my GPU to render my screen natively to 16K resolution on my 8K resolution native screen. And I have the capability to record it through the Nvidia Shadow Play in 8K resolution. Support my YouTube channel, guys, and maybe I'm going to share the modified drivers, and I'm going to show you the ways how I'm doing that in the future. But so far, if you're looking to see the 16K resolution through benchmarks, UHDking.com or iPlay16K.com or iPlay8K.com or iPlay4K.com will be the best resources. If you're looking for UHDking.com as software developer, graphics designer, IT specialist, hardware enthusiast, hardware overclocker, 3D artist, go ahead and visit the Artistic Bytes, and artisticbytes.com will be dedicated to iOS game development and pretty much mobile game development. Sometimes I'm going to release some modes or maybe some mini games for the PCs or even consoles, but most likely I'm going to be focused at Artistic Bytes as founder and CTO at and a project manager at the mobile apps and games development, such as most likely for the iOS as target, but sometimes even Android. Keep that in mind. Look at this, Right now the scene is pretty much getting complex, and this is my gameplay, guys, but as again, I'm not the pro, so do not, you know, pretty much judge me pretty bad. I played this game like maybe 15 times. I tested with the 2 GTX 1080 Ti. The SLI was supported in 8K resolution, but the screen during that time was flickering. I find out how to modify the Nvidia drivers without the flickering screen in 16K resolution. So RTX 2080 Ti and SLI was flickering the screen in 16K resolution, but GTX 1080 Ti was not possible even in 16K resolution, but it was flickering in 8K resolution. Well, I find out how to fix it, so I'm going to show you two Titan RTXs and SLI if the game is still supports SLI, because this is the year 2021. This game engine was slightly modified. They included and the quiet was modified. Everything is still the same, but they included the new visual mode. Look at this right now as a heavy scene going on over here. Look at this, every single object has a beautiful details. I really like this War Thunder PC game. It's just amazing, guys. Look at this destruction. Every single item has a physics to it. The developers did a great job to the details of the game. So when we're going to compare War Thunder to World of Tanks or World of Tanks Blitz, which is for the mobile devices, I really like the War Thunder, and I wish they would create this game for the iOS devices as well, for the iPads and the iPhones, but keep their style, which is the maximum visuals, because the visuals in World Thunder PC game is much better, as you can see, and at another level than World of Tanks, because the models itself feels much higher polygons count into them as 3D meshes, 3D models, and the shaders and textures and complex shading, as you can see, of this game engine in War Thunder PC game is pretty much out visual anything from World of Tanks and World of Tank Blitz, which is even lower quality visuals in the game. But I'm really a big fan of World of Tanks Blitz, guys, and it's going to be some videos in World of Tank PC games and World of Tank Blitz PC games over the UHDking.com, so please stick around for that, especially on the mobile devices. And you probably already can tell I'm a big fan of the iOS mobile devices, such as iPads and iPhones based on the Apple A chip and Apple M chips. So a lot of videos coming over the UHD King regarding that as well, even from the hardcore overclocker, hardcore PC enthusiasts. I'm in love with the Apple A and M mobile chips, guys. They're amazing, the best innovation in 2021 so far, and in 2022 we're going to see even better. And a lot of reviews of the Apple mobile devices or Android devices will be covered over the UHDking.com with some tips and great pretty much information overall. As always, the data will be at multi-angled level provided to you. Look at this, it's just beautiful. And right now the scene is getting more complex, as you can see, and this is pretty much maximum visuals. And those particles coming out of the tanks, this is where the GPU is struggling. Even the Turing GPU architecture is still struggling at the particles, those volumetric particles, and I believe those particles base out of the animated sprites and some volumetric particles, but still kind of dynamic volumetric particles with some physics to it, as we saw those little pieces flying besides the flames. Flames are kind of animated sprites, but the little pieces I believe is volumetric dynamic particles, and this is where Turing GPU architecture by Nvidia is still struggling to render even in 2021. But we're talking very extreme resolution, and right now this scene is absolutely amazing, guys. As you can see, it's the heaviest scene possible, so it's going to test your thermal on your GPU, on your VRAM, and overall video card temperature. And this is a great benchmark by UHD King in War Thunder PC game that's going to work on PC Linux, Macs, and maybe in the future for Android and iOS devices. So I'm going to go ahead and share this benchmark with you because, as you can see, through the technical point of view, this is just unbelievable, and a lot of um, things is going on. Of course, I'm not the pro in War Thunder, but also a great gameplay. I would say the gameplay was great. I scored as #1, and I burned so many tanks in this game. So War Thunder PC game is the best game. Plus, you can fly the airplanes in this game and the ships, not only tanks like in World of Tanks. So it's all kind of different vehicles, tanks and planes and ships. So this game is on another level, and the visuals are on another level. But World of Tanks is kind of great for the people on very low budget. So keep that in mind. Guys, this system right here, this Chinese motherboard with dual Xeon E5-2699 V3, if you're on very tight budget but still can afford some video cards, I advise you to get RTX 3060 Ti, but get it around below $600 if you can. It's going to be a great system with those two Xeons, E5-2699 V3 as workstation, because you can use the RTX 3060 Ti to render in the Blender 3D while rendering some scenes and while browsing the web through the CPUs and do the video encoding through CPU. So it's a great idea. So every time I'm going to switch the video settings, I'm going to reboot the game. So let's go ahead and switch the video settings. As you can see, guys, I'm coming in real time, so go ahead and smash that like button because a lot of information provided to you. At the same time, I'm kind of trying to be focused on the gameplay and data at the right top. This is what you want to do. So I'm going to test now maximum, completely maximum. As you can see, I'm running full screen window mode somehow because the MSI Afterburner is not registering in the game at the full screen. So I gotta run it window mode. So you're gonna see the specs at the right top corner. Somehow the Direct 3D 11 surface that's utilizing Direct 3D 11 API in War Thunder PC game in 2021 is not letting the MSI Afterburner overlay into the game at full screen. So that's the reason why. In the end of this video, I'm going to show you guys the hardware specification, my resolution, and everything for those naysayers. But anyways, running an 8K resolution screen. This is the presets at the maximum visuals, so it's not even maximum as we were running. So this kind of maximum going to be not maximum as we were running at some point, but at some point it's going to be even more hardcore. So let's go ahead and test it. Keep in mind, single Titan RTX video card, and if this game will support SLI, and if GPU utilization will be above 90% per two video cards, per each video card, 90% at least, then we're looking to improve in terms of the FPS in 1.9 times. And that means that it's going to be just unbelievable, guys. Okay? So yeah, look at this. We improve in terms of the FPS by about 5 FPS already. So this maximum presets is not that maximum as we had it. As you can see, GPU, the whole Titan RTX video card is utilizing 280, almost 290 watts, and it's set at 280 watts, but I overclock it, so it's utilizing almost 300 watts right now. But it's not thermal throttling yet, not heavy thermal throttling. Thermal throttling starts at 62 Celsius for Titan RTX video card if you're running the stock BIOS, and today I'm running the stock BIOS and stock Nvidia dual fan design air cooler on the Titan RTX. This Titan RTX has the liquid metal thermal compound paste on it, so otherwise it would be running even hotter than that by about 3 Celsius at least, so it would be like around 70 Celsius. Room temperature right now is 62 Fahrenheit. I turned down the heater just to make sure the room is cooled down. It's almost winter outside, so it's cold, and just to cool down the components. So pretty much this is going to be ideal scenario when you're going to be when you're going to have ideal air cooling solution in your case, in your PC case. So we improve about 2 FPS. So instead of 43, 45, we had 46-48 when there is not too much going on. As again, not by the end of the scene. By the end of the scene, we're going to have so much going on, and pretty much those volumetric dynamic particles will, with the physics in them, will pretty much kill the GPU performance and will slow down our FPS, which is FPS, of course, stands for frames per second, guys. Sorry, I forgot to mention to you, but everybody probably understand that ever played the games. FPS, frames per second. The higher frames per second, the better. At the right top corner, as you can see, guys, at the GPU utilization, we want to keep at 99%. Whatever we keep in the GPU utilization at 99%, the way it is right now, it's amazing scenario. This is how we want to do it, because we are utilizing right now 4,608 CUDA cores on this Titan RTX Turing GPU architecture video card. The CPU utilization we want to keep below 90% all the time. When your CPU utilization reaching 90% or above, this is a clear sign, especially when it's above 90%, this is a clear sign that you need to add at least 2 more physical cores. You can enable the hyper-threading technology, however, on the old school CPU, such as on this one, Xeon E5-2600 series V3 or Xeon E5-2600 V2, and even older, hyper-threading cores, 3.54 hyper-threading cores is equal 1 physical core in terms of the instruction per core. So it's just a virtual kind of logical course. Keep that in mind. So you want to avoid the hyper-threading technology, but you want to enable at least 2 more physical cores. And the reason why I'm not utilizing all the 72 logical cores, because pretty much 36 cores coming from the hyper-threading technology, and I'm trying to have the fast possible instruction per core per each CPU. So I'm disable the hyper-threading technology, as I just explained it to you, and enable only physical cores. But the reason is I'm not running 36, let's say, physical cores and disable the hyper-threading technology, because I'm running the stock BIOS on this motherboard, on this Chinese motherboard. It's not yet modified. I know you can modify the hack the BIOS, and I'm gonna do the video tutorial how to do it and improve the performance 25-30% for free. But the reason is because at stock Xeon E5-2600 V3 CPUs, pretty much not overclockable, and you cannot control the multiplier. So pretty much on Xeon E5-2600 V3 CPUs, when you're running 2 cores, you're running maximum possible turbo boost, which is the maximum possible multiplier. In our case will be 36 multiplier, which 36 multiplier times 100 megahertz on a BCLK frequency will be equal. BCLK frequency, like FSB, will be equal to, for the old school overclockers, gamers that over 20 years of experience, it's almost like FSB. So 100 times 36 will be 3600 megahertz output per each core frequency, or 3.6 gigahertz, and it's only possible with 2 cores, especially on the Xeon E5-2699 V3 CPU. Okay, when I'm having 2 CPUs, I can enable 4 cores at 3.6 gigahertz, advantage of it, which is nice, and pretty much be like almost like a quad core CPU, a little bit slower than that, but Xeon E5-2600 series V3 almost nailed that in terms of the performance, even when it's dual socket CPUs. The data transfer and computer performance is almost like a single CPU. Keep that in mind. By Intel, as again, by Intel. Mobile CPU by Apple will be so fast when comparing to Intel, even single core performance or multi-core performance, that is just unbelievable. That's why I'm a big fan of the Apple mobile CPUs and mobile chips, mobile GPUs, but today is not about that, guys. So as you can see, alright, so to be able to run 3.4 gigahertz, I need to have 3 cores enabled only, and every single other course must be disabled in the BIOS, as again, without the BIOS hacking or modifying, just to be safe, right? So 4 cores will be 30 3300 megahertz, 4 cores per CPU, or 3.3 gigahertz. Okay, and I can run 4 cores, total 8 cores output. This is exactly what I'm doing today. 3.3 gigahertz, 4 cores per CPU, 8 cores output, so it's equal to almost 8 core CPU. It's acting like 8 core CPU, 5000 series i7 Extreme CPUs by Intel as desktop CPUs. So even if it's dual socket, but it's acting as 8 cores pretty fast. The latency delay almost none, comparing to that type of single CPU, single socket motherboard CPU performance. Alright, right now we're gonna boost it up, we're gonna decrease the FPS. It's going to be a lot of volumetric dynamic particles, as you can see, based on the animated sprites and particles, the little particles that have physics in them. And I think they probably should utilize the Nvidia physics, but just because the AMD Radeon's not using that technology, that's why they didn't do that, and they're using some different method of the APIs for the physics while enabling those physics to the particles, because as you can see, particles is recognizing 3D mesh and is going around it. Maybe it's not dynamic, but it's look like to me, I think. But the every object, as you can see, 3D mesh, and you see even those little pieces after the destruction, every single that object has had the physics in them. So I believe the particles dynamic and have the physics in them as well. But beautiful scene, guys. FPS is beautiful for single Titan RTX video card. It's just unbelievable. So RTX 3090 video card is almost 2 times performance, but I find out not exactly 2 times performance, to be honest with you guys, especially when I compared it. But as again, it depends to the game, but in newer games it's going to be 2 times performance of the Titan RTX. So RTX 3090 video card in the newer games that was released in 2020/2021 will demonstrate almost 1.9 times performance over this performance right now, even on the same system with the same 2 Xeon E5-2699. Keep that in mind. But 2 Titan RTXs is hairs faster than single RTX 3090 in older games. Keep that in mind. But RTX 3090 can be overclocked, and then it's going to match the 2 Titan RTXs. And it's better to have single RTX 3090 than 2 Titan RTXs, because not all games supported SLI, and newer games that are going to utilize DirectX 12 API is not going to support the SLI, and it's going to be oriented towards the multi GPU, but as again only if developers will develop that type of feature and create the game engine multi GPU capable. And as we saw, it's not happening. Developers are lazy, so this is what's up, guys. Beautiful performance. It's playable. War Thunder above 30 FPS is playable, especially when the FPS is 40. It's very playable, and this is pretty much with the maximum visuals. The game looks amazing in 8K resolution. Please, as again, switch YouTube player to 8K resolution, because I recorded in 8K resolution native. I'm not going to edit this video. I'm not going to make it pretty. I'm just going to post it through the FFmpeg++ application, and it's going to cut the video size by half, but it's going to keep the same quality. It's going to be like 100 megabit per second bitrate instead of 150 megabit per second as I'm having right now, recording with the Nvidia Shadowplay modified version in 8K resolution. So, but it's going to cut the size, because the output of this video probably going to be 130-150 gigabytes of video file, and YouTube doesn't accept that file size in 2021. So I'm using the FFmpeg++ application with the UHD King profile in 8K resolution for YouTube. That will be as a profile available for you guys in my application that I'm developing, and it's going to give you pretty much, it's going to give you the small possible file size, but the best possible quality. Oh, look at this. This is the most heaviest scene, and pretty much it's going to eat up that FPS, but still above 30 FPS, so pretty much comfortable. So RTX 4000 series flagship video cards, guys, going to be amazing. It's going to be amazing in both ways, for 8K resolution and above. and beyond, which will be the 16K resolution. And by the way, the Titan RTX video card is capable to run the War Thunder in 16K resolution, and I'm going to demonstrate it to you guys over the hdking.com or over the iplay16k.com. Do not miss it out. It's going to be a great gameplay. It's going to be a low FPS though on a single Titan RTX video card, but as again, if the War Thunder PC game will support two Titan RTX in SLI with the new drivers, which I don't see a problem. All the old games running no problem and SLI with the new drivers, with the drivers in December 2021. So if this will be the case, if SLI will be supported, then we will be pretty much maybe even playable in 16K resolution. I don't want to spoil it for you, but go ahead and check it out. And 16K resolution is 133 megapixels rendered in real time, guys. And it's only possible with Turing GPU architecture, as I tested. Titan XP couldn't grant us 16K resolution because, as again, it has only 12 gigabyte of the video RAM capacity, which is the frame buffer. And 16K resolution requires more than that, because right now, as you can see, we are utilizing in 8K resolution, we are utilizing about 14,000 megabytes, so about 14 gigabytes is utilized. So be able to run this comfortable in 8K resolution, you need to have at least 16 gigabyte of video RAM, video card. So RTX 2080 Ti video card is not going to handle it properly, so it's going to lose a lot of FPS, because as you saw, utilization was about 14 gigabytes, and RTX 2080 Ti is only capable with 11 gigabytes video RAM capacity. So pretty much it's going to offload a lot of data into the system RAM from a VRAM to avoid any crash, and it's going to compensate for the FPS, because DDR4 is not fast enough as GDR6. GDR6 is about 8 times faster right now than our DDR4, because DDR4 right now is running 2133 megahertz, while the Titan RTX or RTX 2080 Ti video card GDR6 is running at 14,000 megahertz, but right now running 16,000 megahertz, which is 8 times faster. Okay, so what I'm gonna do, guys, I'm going to go ahead and switch the resolution now, not the resolution, but the preset. So I went so much deep into the my tests with you and provided a lot of results and data to you. Hopefully you loving it. So we were running anti-aliasing though, HQTAA at 8K resolution. So without it, guys, we will improve in terms of the FPS. However, Turing GPU architecture is not scared of the TAA anti-aliasing. It's just pretty much chucking it like it's nothing. It's gonna eat it like it's nothing. For Turing GPU architecture, also the Pascal wasn't scared TAA, but Maxwell GPU architecture didn't like TAA. Keep that in mind. It was kind of taxing about 30-40% of the performance in terms of the FPS when it's enabled versus when it's not. So I'm going to switch to medium now. We don't need to test the high, and I'm gonna restart. So I'm gonna restart it, and we're gonna restart the game every time we're going to switch the presets, because War Thunder PC game requires the restart, and we're going to go ahead and follow it just to make sure that everything will be registered correctly and every single texture will be loaded correctly, and every single preset and effect in the game, post effects, will be just right there. Okay, we're loading up, almost there. And as again, on the background, this is my photo out of my old iPhone of the whole system. This is how the system is looking right now. And I have a beautiful Cougar Panzer Max carbon fiber and a gray, light gray, gun gray aluminum PC case, which is a great window and beautiful case, by the way. But right now it's not in the case during the tests, but after all the tests will be done, I'm going to put the system in the case, and we're gonna move on to a different PC system for the test, guys, over the UHDking.com. But as again, UHDking.com is not only about the PC hardware. Keep that in mind. Graphics design, 3D animation, software development, game development tutorials will be provided to you. So we're gonna learn a lot of IT. So let's double check the preset. I just sipped some water, guys. Sorry, I did a little pause. So medium preset, as you can see, this is how medium preset looks like. Okay, untouched. And we're gonna go ahead and go community, replace, and use my replay. Okay. And as again, we're not gonna move the camera. It's just gonna load it up the way it should. I'm gonna turn down the people's names. I'm gonna keep it plain and simple. Okay. Look at that FPS, guys, above 80 FPS average. And as again, while it's recording with Nvidia Shadow Play, it consumes 3 FPS. So go ahead and add 3 FPS to the FPS counter every second to receive the FPS without recording. The latency delay below 15 milliseconds, so it's going to be without any stuttering. It's going to be a gorgeous experience. It's going to be a very fast experience, and you're going to enjoy it. For those people who's looking for very fast FPS, this latency delay below 10 milliseconds right now while it's recording is going to be latency delay like 100 FPS, because below 10 milliseconds is pretty fast. The speed in during the gameplay is not pretty much considered in that algorithm only with the FPS. It's also, you gotta consider the latency delay in those ms, which is the milliseconds, and below 10 milliseconds the game play, especially when it's below 5 milliseconds. It's just a crystal fast. But above 20 milliseconds, this is where you start feeling that stuttering, and above 30 milliseconds, especially above 40 milliseconds, this is where stutter starts, and above 50 milliseconds it's just stuttering everywhere, and it's pretty much not comfortable gameplay. But it can be benchable, and the purpose of this video is again to benchmark it so we can compare with the future hardware, future GPUs, future video cards, future CPUs, future PC systems. Alright, so Titan RTX, of course, overclocked by 100 megahertz additional on the GPU, and by 2000 megahertz additional on the VRAM. As I already told you, VRAM on Titan RTX or RTX 2080 Ti video card will be the same, GDR6 by Samsung, and pretty much it's going to be, I believe it's by Samsung, and pretty much on both video cards. And it's running 14,000 megahertz, but it's overclocked by 2000 megahertz, which is boosting more bandwidth, and we can push more textures and faster those textures to be pushed per cycle. Keep that in mind. GPU utilization is excellent even at medium, 99%. We don't want to keep it below 90, because below 90 this is where you're not going to utilize all your CUDA cores. Look at those details. Even at medium, everything looks amazing in 8K resolution. Some people will tell me, well, the game doesn't have 8K resolution textures, and you're wrong. The game doesn't need to have 8K resolution textures. Even if the game would have 4K resolution textures, right now on the screen, this tank is a 4K resolution texture fully will be applied on this tank. And I'm pretty sure this tank has the turret textured in one texture, the whole pretty much frame texture in another texture, and it's going, if it's going to be 4K resolution each, then the turret is not in 4K resolution pixels. That means that you're not going to render that 4K resolution turret texture that is in 4K, even if it's going to be 4K. So to be able to render the turret in 1080p resolution texture, you gotta run 8K resolution, just like right now, because that little turret right now will be 1080p on 8K resolution. Okay, this is exactly how much 1080p. So in this way, you're going to render every single pixel of that 1080p texture. So hopefully, guys, this makes sense. Okay, and that's why the visuals even looks on another level, and people who play the game for a long time can tell the difference immediately. Okay, but you gotta play the game a little bit to understand that. So you're gonna adapt to your screen, and then when you're gonna see this crystal clear, you're like, wow. And this is a medium, keep that in mind. And still the details are popping everywhere. Look at that rock detail at medium when the texture is already blurred out. but still unbelievable, guys. And you can see the grass is not here, and we can see the preloading bushes and preloading the streaming textures. And they have a radius. Even if you're going to have a RAM disk, if you're assuming that RAM disk will help you, nope, it's not going to help you because it's a radius of the preloading, guys. So as again, RAM disk, for those people that are going to see my video about the RAM disk, when you're going to use above 100 gigabytes of your system RAM as the storage, which will be fast, but there is no need for it, guys. I even don't see any need above the my Crucials MX500 SATA 6. They're so fast, there is no need above it, because the Nvidia ShadowPlay cannot record 8K resolution video at 60 FPS just to go above 500 megabytes per second of the data transfer that allowed on this MX500. It's not even going to reach 100 megabytes per second. So I mean, you can buy the M2s, M.2s inside those even flash storages, but you're not going to take any advantage. However, the RAM disk could take an advantage, especially if you're running server and a lot of people accessing the data. So the faster the RAM disk output as a storage for crucial data to access, the more people can access, or people can access it faster. Keep that in mind. And the RAM disk is not overheating, which is a great thing. So I would say RAM disk, you can utilize the RAM disk when most likely when you're going to record 16K resolution videos, but it's not at that time yet. But as again, my videos are in the future, so maybe this is where you want to buy and build DDR4 system and put like 256 gigabyte of DDR4 if it's going to be cheap, and build that system, like the whole system, for $200 and use it as a RAM disk and encode on that system, let's say 16K resolution at 60 FPS. But 16K resolution at 60 FPS in real time encoding, video encoding, is not going to happen even in 2025. I think 2027-2030. We are not there yet. It's going to be, I think, 3D layers, cores, design, and the CPUs just to eliminate the latencies, and then I think it will be possible. Right now, it's not even possible to decode the 8K resolution at 60 FPS with CPU. Keep that in mind. So in 2021, so we are at this type of times. Look at this right now, that heavy scene, and our FPS still above 60 FPS and medium. So a lot of people would be playing like this. But competitive players probably will turn it down to low so they can spot the enemy at the huge distance, and then they're gonna see all those bushes, all those details. But the truly professional player, when he's playing in the true beauty, recording it and dominating, not those who turn down everything at low and playing, you know, when every single object is visible immediately. But it's up to your style of playing PC games. I really enjoying the 3D visuals, guys. 3D visuals is the most important factor for me. Otherwise, just seeing those square geometry over and over and over again is kind of you know, boring. But I really like the details as an artist, and just, you know, just to see some artistry. And this is where the maximum visuals, this is where the resolution brings those details. So hopefully a lot of people understand. And in 2011, when I was running a 4K resolution with 4 Radeon R9 290s, Crysis above 4K resolution, I did it in 2010, 2011, people were saying that 4K resolution, the eye barely can see. That means that 8K resolution I cannot see almost at all. But it's just bunch of cuckoo and nonsense, and do not even follow those type of people. They're all against the innovations and against the progress. They're not here for us, guys. And we as a human beings, we want to progress. And UHDking.com, iPlay4K.com, or iPlay8K.com, or iPlay16K.com YouTube channel is all about innovation, progress, how to be an engineer, how to be a producer, not as a consumer. So I'm going to show you all kind of different sides. I'm going to show you consumer side and producer side, and throughout my YouTube channel, you will learn how to think differently, and as well, hopefully, you will learn the software development, which will um, create a great analytics analyzational skills, because when you're going to learn the software development with your heart, pretty much you will envision to create anything in your head before you're going to create it as a software and bring it and share it with the people, and it requires a lot of skills and analyzation to do so, guys. So that's why I believe the software development is the king of all arts. And usgking.com YouTube channel, as again, is not going to be limited to the games. Look at this. I really like the level of details in this game. They pay attention even on the concrete track. Sprites are different, and I really like what developers did in War Thunder versus the World of Tanks and World of Tank Blitz. They're charging more, by the way, if you trying to invest some money in the game, and delivering less. So I'm really in love with this game. As you can see, guys, I'm not the pro, but I did a great game, and it's a great benchmark. As again, the purpose of this replay is to be as a benchmark, and it's a lot of burning particles, and scene starts with a low scene, and it's gonna pretty much heat up your video cards and the whole system, and then it's going to be pretty much burning in the end, which is great from any point of angles of view. Hardware enthusiast, PC overclocker, gamer, and to use this replay as a benchmark while you're testing your system versus my system, or let's say versus my workstation in 2021 versus my gaming rig in 2021 versus my gaming rig in 2022. Let's say it like that. And I think this replay has the best purpose for it. A lot of 3D meshes on the level, a lot of dynamic, hopefully a lot of volumetric, but hopefully dynamic particles, and yeah, level of details, a lot of players, a lot of geometry rendered. So pretty much stressing the GPU and CPU to the max. So 8 cores, guys, is more than enough, and so for me, I decided to do it because 300 megahertz doesn't make any difference. Maybe maximum was going to bring 1 FPS, because the difference between running 3.6 gigahertz with just 2 cores per CPU total output 4 cores versus running 4 cores per CPU total output 8 cores but 3.3 gigahertz, it's only 300 megahertz, and 300 megahertz maximum 1 FPS, not a biggie. But if the difference would be like 800 megahertz, 1000 megahertz, or 1 gigahertz, most likely I would disable the cores just to boost it up, but not for this type of system, not for this type of scenario, not for this type of Xeon's E5-2699 V3 CPUs, guys. So hopefully this makes sense. The game is beautiful, loving it. I love the sounds in the game too, and the whole level design is just so in depth comparing to the World of Tanks. But as again, I'm a big fan of World of Tanks Blitz on the Apple mobile devices, so more videos will come about it, guys, and you will see the World of Tanks developers will improve the visuals, and both of those developers are ex-USSR developers, so post-Soviet countries developers. Keep that in mind. And the game's also kind of similar in terms of the visual interface to each other, and I'm not sure why they didn't invade the interface. And the core of War Thunder will be the interface. The interface is so ugly and so not user oriented. It's confusing the user to the maximum possible way that you can imagine. So I would keep it simple: gold, silver, and etc. But otherwise, people can lose, and those symbols doesn't reflect to a real life user interference. And I think the user interface is a bad job. As a graphics designer, as 3D artist, and software developer myself. Okay, so we saw that, guys. Let me go ahead and quit, and I'm going to switch now to low. And this is going to be the last preset, and we're going to go ahead and wrap it up. And the last thing will be to show you the specs, the hardware specs in depth. So as you can see, I'm running resolution auto, which will be our desktop resolution, and desktop resolution is 8K resolution, 7680 pixels by 4320 pixels. So medium was great, but let's go ahead and create completely medium just to test the CPU, just to see how well the 8 cores 4 cores per CPU will be utilized on this dual socket motherboard. As again, guys, you can modify the BIOS and boost up all the cores to 3.4 gigahertz if you're capable to cool it, or maybe even 3.6 gigahertz when all the cores are utilized. And if this will happen, 3.4 gigahertz slash 3.6 gigahertz for all 72 logical cores, the system will be faster than 3960X for sure. I mean 59, yeah, 3960X, or maybe even half faster than 3970X. If this will be the case, I'm going to be in heaven, and I would say this is the best ever workstation that I built out of the scrap, and only $400 invested in a brand new motherboard. But as again, from China, made up of the scrap probably, but made up of the good scrap. Everything is looking great, like new, and the CPU was like new. The CPUs were like new from the probably from data center. It was from a local e-recycle company. $125 per each, guys. I'm gonna include in video description from Amazon, which I like the sellers, for you to get from great sellers the same specs if you're looking for. But do not buy the Xeon E5-2699 V3 if it's above $200. Keep that in mind. Below $200, it's a steal. It's a great buy. Okay, so let's go ahead and verify the graphics. Minimum preset. However, MSI Afterburner is right here. Okay. Okay, minimum preset. This is how the minimum preset looks like. Guys, I'm going to show you on this system what Thunder in 10K resolution, 12K resolution, and 16K resolution over the UHDking.com. So go ahead and check it out. So let's go ahead and do the replay. I forgot to let you know, but it's going to be a great videos. And we're going to test the same benchmark. So I'm going to cover in a workstation, and then I'm going to show you on very fast gaming rig, which is i9-9900K overclock at 5.4 gigahertz, because most likely I'm going to use only 4 cores. It's stable, almost stable at 4 cores when it's not fully utilized at 5.4 gigahertz, and pretty much it's going to be as fast almost as Intel 12900K in terms of the frequency, running like at 5 gigahertz. So pretty much almost like stock 12900K that system will be, and it's nice to see. So pretty much that's going to be a system from 2022 when it's overclocked to 5.4 gigahertz i9-9900K, and it's nice to see how the whole deal will be here. So we want to keep our eye, guys, at the FPS, latency, delay, GPU utilization 99%, still 99%, nice. And temperatures and load on the CPU. Overall CPU cannot reach above 90%. Otherwise, we gotta add some more cores, because there is a possibility with thermal throttling just a little bit. Keep that in mind. Okay, this is going to be the last test. Above 150 FPS, I just saw a couple seconds, but as again at the scene when we were looking at the skies. But still about 130 FPS average. So right now there is a maximum stress on the CPU and less stress on the GPU, and the whole video card receiving less stress as possible, but still GPU is utilized at 99%. This is why I love 8K resolution, guys, because it's utilizing your CUDA cores the way it's supposed to. Because when you're running Titan RTX and 1080p, you will never achieve 90% of the GPU utilization, no matter what kind of game you're running, except the RTX technology games. Because it's not capable to utilize the Turing CUDA cores. Turing CUDA cores so fast, it's just processing that instruction faster before the whole CUDA core is utilized. However, this is a 1080p, and it doesn't matter what kind of CPU running, to be honest with you guys. It's not going to compensate that. You will never utilize your GPU at 99% at 1080p when we're talking Titan RTX video card or RTX 2080 Ti video card. But if you want to utilize an 8K resolution, utilizing Turing and utilizing the Ampere, which is the RTX 3090 flagship, without any issues, guys, at 99%, without any issues. The Ampere will be utilized here like at 94, 92, but still above 90. Ampere is fast, so our RTX 4090 or the RTX 4000 series flagship video cards, if it's going to be maybe next Titan, guys, will be probably below 90 at 8K resolution at lowest, at minimum possible settings as I'm running right now in this game. This is based on my predictions as a hardware engineer, and because it's going to be fast, it's going to be so fast that this game engine won't be able to utilize all the CUDA cores for the rasterization or under the DirectX 11 API and within this game engine. Keep that in mind. But look at this, at minimal presets, still the game looks great. Of course, we can see the sprites creating the bushes, and we saw it even at the maximum visuals. So they gotta do with that type of technology in terms of the bushes. I think instead of putting the planes and set the sprites on them as the textures, they already can do the spheres, or they can do the cylinders. But the problem is you want to make it shaking, as you can see, because when you're shaking the plane and that sprite as that bush applied to that bush, the texture, you can shake that plane, rotate it a little bit, and it will create that effect that it's moving, right? So this is how they're achieving as the game developers. But they gotta come out with something so we don't see those type of planes, but you can see these planes when you're approaching the object, and it's ruining the visuals. So instead of RTX, they probably should think how to improve the visuals. Because why PC gaming is that? Because they did not introduce any new forms of 3D rendering, any new ways that's going to improve that visuals to another level, to create more photorealistic kind of feeling to it. They did not introduce it since I believe 2013, since the Battlefield 3. And why I believe it is this way? Because I believe the gaming industry, based on this type of ideas, first is going to go like a cartoonish, then cartoonish tuning into the photorealism. Then they're going to produce the new video cards. They're going to do cartoonish again. This is going to be a new cycle. That the new cycle goes into the photorealism. Then again, the cycle repeats. Cartoonish, photorealism. Cartoonish, photorealism. So right now we're at the level of the cartoonish. Okay? It's kind of lookish like the old school photorealism level to it, but it's still cartoonish of the new kind of era of the game engines. So it will take, I think, 5-7 years when we're gonna reach a new ways of the visuals, which will be the photorealism, and then it's going to be as again new age of the 3D rendering era, and then it's going to be as again cartoonish, and then as again as photorealism. As you can see, at minimal presets, those particles are almost gone. We're not rendering a lot of those particles. The FPS is crazy fast, above 160 FPS at the right top corner. The latency delay below 10 milliseconds. That means that it's running so fast in 8K resolution, and you're still receiving the beautiful visuals. Right now, this 8K resolution, guys, on the 8K resolution screen, rendering in 8K resolution native, it looks like 4K resolution at least at medium, but I would say 4K resolution at almost at high. This is how it looks like, because first of all, at 8K resolution, it's creating this those native anti-aliasing. So those edges on the 3D mesh is anti-aliased, and you don't see those edges, especially on that line. You can see it on a lot of lines, the straight lines. When it's not going to be anti-aliased, when you're going to run 4K at minimal, it's going to be edgy, even at 4K. At 1080p, you're gonna see those edges like so much, almost everywhere at minimal visuals. So 8K resolution at minimal, at least anti-alias all the edges that running straight, or those 3D meshes. Okay, and then it's rendering more pixels, more data is rendered, and it's automatically bringing us to another level of the visuals. And you can see when you're switching 4K resolution to 8K resolution, even minimal presets, you can see the difference. And the reason why it is because, as I already explained to you during the beginning of this video, because it's pushing more pixels, it's rendering more pixels, more data out of the textures of those every single 3D mesh. Hopefully guys this makes sense. But of course the presets are blurring it out by rendering less data. It's cutting the data, so it's rendering less details, but still, because it's still pushing more pixels, it's kind of on another level of the visuals, even if it's not like so by mathematically developed by the developers, but just because the way mathematically the resolution is created under the 3D rendering, it's still improving the quality. That's why the higher resolution in PC games, in any 3D games, will improve the quality itself. Okay. And about the textures theory, I explained it to you as the 3D artist, guys. Go ahead and watch the beginning of this video. So hopefully you receive a lot of information by just watching this video. Even if you're not 3D artist, you really receive a lot of data, because my experience coming to you as a 3D artist. Go ahead and check out the hdking.com YouTube channel. Go ahead and check out my freestyle tutorials that I was not reading it, I was doing it freestyle. You're gonna see my knowledge as 3D artist, 3D animator is just on another level, and I'm combining that knowledge as a software developer, graphics designer, and hardware enthusiast, hardware PC overclocker, and hardware engineer, and software engineer, and the data, the information that provided during this video is just on another level, guys. So don't forget to smash that like button, and it's on my time and on my money. So go ahead and visit my sponsors. You gotta watch my sponsors and smash that like button, share it with the friends. More support I'm going to receive by you, the more information, the more time I'm going to invest towards my YouTube channel, the more great videos will be, the more innovations, yeah, the more great stuff will come out. As again, I'm about, guys, to create a great softwares in the future, and you're going to find out about it over the hdking.com YouTube channel, because from the artist, from the developer, right? Look at this. The particles doesn't look great now, and it's a less sprites at least, as you can see, and less dynamic. If there were dynamic, those volumetric particles, the little pieces from the blowouts, they were like flying away, kind of emulating the physics. Maybe it was the physics in the particles, or if it's not, at least it was emulating. But at the minimal preset right now, we didn't see it when that vehicle blew out a couple seconds ago. So crazy about 140 FPS in 8K resolution ready on a single Titan RTX. If SLI is supported, and if SLI will be utilized like that, 97-98%, which I have a little bit doubt. I think it's going to be utilized like 92-95% per GPU for 2 video card scenarios. Then we're going to be like, guys, above 200 FPS, or whatever the maximum cap, FPS cap, maximum capacity FPS is possible. For this game engine, probably going to be rendered with 2 Titan RTX and SLI if GPU will be utilized above 92% per each GPU in that scenario. As again, I didn't try it yet. I'm about to try it. My second Titan RTX is computing the Bitcoin, guys, that I'm going to invest towards the YouTube channel. So don't forget to support me. Smash that like button, please. And yeah, as again, we're about to finish it up. I'm gonna show you, we're gonna talk about the hardware for those hardware gurus in the end of this video. Less gaming stuff, more hardware stuff, less 3D stuff, but in few minutes we'll be available with the beautiful information for you guys. So would I build in 2022 Xeon E5-2699 V3 dual system? Yes. Even if it's $400, yes. Why? Only for 3D rendering in 3ds Max utilize beautifully every single 72 logical cores, or Blender 3D or Cinema 4D utilize beautifully, and 8K resolution encoding when the software, and in my case FFmpeg++ software that I'm using, I'm re-encoding every single video for it just to cut the file size and not decrease the image quality. It's possible, as again, through FFmpeg++ application, through the UHD keying profile, and it's utilizing, guys, like 64 cores at least, and this is where I'm taking advantage. And it's re-encoding much faster than Adobe Premiere, Adobe After Effects, and Sony Vegas by about 2 times at least when we're talking 8K resolution. My FPS of 8K resolution video encoding from 8K resolution video file to 8K resolution video file is 12-13 FPS on a stock 2 Xeons E5-2699 V3 with the 72 logical cores, which is 36 physical cores, and hyper-threading technology is enabled. 12-13 FPS, frames per second. It's great real-time render, so keep that in mind. That's why I love those Xeons, and it's exactly not for the games. For the games, I would use the different system, but you can game and you can have fun, and pretty much I wouldn't switch right now to my gaming rack. This is how great it is in 2021/2022. So let's go ahead and close that. We saw everything which we need to see in the game. We're gonna go through a hardware now. Let's go ahead and go through the hardware. First of all, I'm going to show you through my Nvidia driver. Let me open up the Nvidia driver that I'm running the native 8K without any DSR, and the presets, that maximum preset was used. So let me zoom in, guys. Okay, manage 3D settings. So this is no DSR and maximum performance. This is the presets, quality. Okay, very important because performance will give us the higher FPS. Let me close that, and let me zoom in here, guys, and talk about the hardware now. It's time. So as you can see, I already told you, plus 100 megahertz on the GPU overclock additional through MSI Afterburner, plus 1000 megahertz on a GDR6 of our VRAM, which is the video RAM, on each Titan RTX. Today only one Titan RTX was installed in the system, and I was running only one Titan RTX, plus 1000 megahertz, which is 2000 megahertz output, so from 14,000 megahertz up to 16,000 megahertz, 100% fan rotation. Power was maxed out. We didn't thermal throttle heavily, but without liquid metal thermal compound paste, temperature would be at least 3 Celsius higher. Okay, this is how Titan RTX under the overclock score versus this 8-core, 4-core per CPU system, which is again the 72 logical cores will score on those two Xeons much faster than that, but as again it's no match. A dual Titan RTX is scoring above 300 FPS when it's overclocked, keep that in mind, which is 2 times almost everywhere. Somehow Titan RTX GDR6 has low write and read memory capacity during this test. As a result, almost below 20,000 megabytes, and 2 Titan RTX is like almost 30,000 megabytes, but maybe because it's processing the data so fast that it's not capable to load up the benchmark. There is a possibility, because I'm pretty sure GDR6 should be much faster than GDR4, running 2133 megahertz, because GDR6 running right now 16,000 megahertz, 8 times faster. But pretty much everything makes sense. Xeons was running 64-bit machine code, which is so fast, and the most fastest possible computing scenario for the Xeons, and for any desktop CPUs, and or any Intel CPUs. And OpenCL was run same scenario for the Titan RTX, the closest possible emulation. This is, guys, everything what you need to know about those systems. So quad channel opens up when you're running 4 cores per CPU only and 2 CPUs installed on this Chinese motherboard, and this opens up pretty well, almost double bandwidth, versus the 128-bit, which is dual channel, and this quad channel is 256-bit. Nice. socket 1, socket 2, 4-core 4 threads. Explaining to you, 45 megabytes level 3rd cache was shared per 4 cores only. It's sharing between 18 physical cores, but right now it was sharing between 4 cores, so above 11 megabytes of pretty much cache was shared level 3rd. Cache, motherboard, Titan RTX was running PCI Express 3.0 16x lanes, 178 gigabytes quad channel, CL15, not CL10, doesn't recognize it right, but frequency recognized correctly. Titan RTX 384 bits, both Samsung DDR6. I was correct about the Samsung and the Titan, but I think RTX 2080 Ti also running a Samsung. Keep in mind that RTX 2080 Ti would show 10% lower FPS that you saw during this test. However, when the VRAM utilization went above 11 gigabytes, that means that RTX 2080 Ti will struggle, will show much lower FPS than 10%, and maybe even not loaded with all that benchmark that I did, because I didn't test it fully RTX 2080 Ti under this type of conditions. And this is how it scored, guys, versus the 5000 series Extreme CPU by Intel, but that was running 16 threads, and which is the hybrid threading technology is enabled, and my hybrid threading technology was off, which was disabled, so only 4-core 4 threads. Very nice scenarios. I'm pretty sure I'm going to match him if I'm going to enable the hybrid threading technology. Okay, so pretty much that's about it. And let me show you CPU ID. So I was right. This scenario 33 multiplier times 100, and over here uh, it's going to tell us about the scenario about the multipliers right here. Everything what I explained to you already during the gameplay. So this is the multipliers. If you want to use the higher multiplier, it's like emulation of the overclock by Intel automatically. It's called Turbo Boost. However, it's not controlled by the user, but you can fake it by disabling the cores, and this is why I disabled the cores in the BIOS. So I'm forcing that multiplier automatically. Even when CPU is not at 100% load, even when CPU is at 30% load, it's going to use 33 multiplier because I use the 4-core 4 threads per each CPU, okay? No hyperthreading technology, but hyperthreading technology is again going to slow us down a little bit, create some higher latency, but it's going to help if you need, let's say, 16 logical cores. So this type of approach has some future, as you can see, if you're going to enable the hyperthreading technology still for the PC games. But this type of approach is only as workstation, and it has a lot of future, guys, in 2022. Okay, on the low budget, folks. For the budget, like $450 for a motherboard and 2 CPUs, this is just unbeatable. So I'm showing you guys what kind of technology this system supporting. As you can see, it doesn't support Turbo Boost 3.0, which is the, I believe, came with the 8000 series or 7000 series, but it's supporting Turbo Boost, and so it's doesn't allow us to unlock the multiplier. Okay, showed you everything what you need to know. Information about the motherboard real quick. Chinese motherboard, unknown. Chipset, their chipset, they call it Dual X99, but it's pretty much C612 server chipset motherboard, I believe. Okay, everything what you need to know is right here, guys. Okay, as you can see, it doesn't support above DDR4 2133 megahertz. So whoever tells you otherwise, most likely they're lying. It's saying the IDAS 64 engineer version saying that it's supporting up to 192 gigabytes, but I believe the board supporting 256 gigabytes. I will try to test it and let you know when I'm going to review this board and when I'm going to show you how to pretty much modify the BIOS and unlock the 25-30% of extra performance on those two Xeon E5-2699 V3 CPUs that are logged by Intel. It's going to be a great step-by-step instructions, guys. So you can visit your local electronics scrapyard or recycling company and pick up and build up a beautiful system as workstation, and be as YouTuber, as 3D artist, graphics designer, as you know, even play some games and let your kids or yourself play some games. So what's up? Let me show you the GPUs. Yeah, let me show you the GPUs. This is the GPUs. SLI was disabled, only single video card, and only single video card was installed. And pretty much everything was explained to you guys, right? That's it. I guess today was December 2021, December 3rd, 2021. Thank you so much for watching. Have a great day. Don't forget to smash that like button. Support me. Visit my sponsors, UHD King, I Play 4K, aka I Play 8K, aka I Play 16K. Till the next time. Check out those videos. Check out the video description. Visit my sponsors. Positive comments. See ya, guys.